Real pleasure to be here. I thank the organisers for the invitation and the opportunity to present a case for a novel therapeutic for Alzheimer's disease and a demonstration that it is a legitimately meaningful and practical way of tackling at least a subgroup of Alzheimer's disease patients. Alzheimer's disease is a horrible disease, and so far the multiple failures of clinical trials only underline the difficulty and the complexity of the disease. And we should not be discouraged by those negative data. We should learn from them. And we should be braver and bolder and come up with solutions that we believe in. Memtin is a rename of a protein that has been known as leptin. It has been in the past tried against obesity, so it's a repurposing effort. And we are going to be developing it as a replacement therapy for a specific subgroup of Alzheimer's disease patients. And this is based on a number of positive data, compelling data that come from a spectrum of preclinical studies all the way to clinical studies. And this includes 10 years of preclinical work conducted by Neurotez and its collaborators, and corroborated by independent groups around the globe. Clinical studies involving longitudinal and cross-sectional observations, and a few anecdotal interventional human studies, all of which in combination and independently and more strongly in combination, supporting leptin's role as a neuroprotectant, as a cognitive enhancer, as an agent that decreases levels of A-beta and phospho-tau. And these not necessarily being, according to the team, culprits of the disease, more likely biomarkers of an underlying pathology. And also associated with a lower risk for Alzheimer's disease. So as a replacement therapy, it is a relatively de-risked, multifunctional approach, and has the potential to be not only therapeutic but also preventative in nature, because of the known safety profile that we do have about this molecule. So I'm going to show you some of the data that support our thesis. All the way back when people were studying novel mouse, this is a mouse characterized by leptin deficiency. Both leptin gene copies are mutants, and generates this super obese phenotype. In addition to the super obesity, they also have a very small brain volume and behavioral deficits, all of which can be corrected by leptin treatments. So these were the first kind of hints that leptin has a role in not only as a metabolic agent, but also an agent that influences brain function and structure. And in 2001, there were the first epidemiological studies shown on the right, where they showed that Alzheimer's disease patients with a BMI lower than 20 had leptin levels significantly lower than vascular dementia patients, underlying the potential of a leptin signal in Alzheimer's disease, a specific association with risk for Alzheimer's. And more recently, in 2009, in fact, by the same group that was represented today from Boston University, that in the Framingham study involving 800 individuals, followed for a period of 10 to 12 years, those that had the lowest leptin level, the first brought off at baseline, were 4 times more likely to get Alzheimer's 10 to 12 years down the line. In addition, they recorded MRI images of these patients and significantly also supported the fact that low leptin is associated with brain atrophy in addition to risk for Alzheimer's. Our own study, we analyzed data from ADNI database, and they had a subgroup of patients that had both plasma and CSF samples for they measured leptin, and we corroborated the link of low leptin to MCI in Alzheimer's disease patients. More specifically, 70% of both men and women with MCI had leptin levels that were lower than the median value of that found in normal elderly. So there's a significant portion of MCIs and Alzheimer's disease that do have low leptin levels. Preclinical studies. Here are some cell culture studies. Leptin treatment resulted not only in the reduction of A beta in the cell culture medium, but also in a dose in a time-dependent fashion, but also the levels of a number of different phospho-tau epitopes. In animal models, this was also corroborated. We did observe a reduction in amyloid load in the brains of the CRNB8 mice. These overexpress human APP with 2 FAD mutations. They have a particularly aggressive expression of pathology. Leptin treatment also reduced the phospho-tau levels of a number of native tau epitopes. More relevant for an approval of a drug related to leptin as a therapeutic. These animals also, following treatment, exhibited an improvement in a number of behavioral tests. Here on the left, the normal object recognition test. After 4 weeks of treatment, transgenic animals receiving leptin were indistinguishable to wild-type animals and significantly improved over transgenic animals receiving saline. On the right, the fear conditioning, both contextual and cued, leptin treatment again resulted in improvement in performance. We also did a number of other tests that more or less provide the same picture. More interventional studies, at this time with humans. There were a number, up to about 4 or 5 studies that involved the treatment of general muscular dystrophy patients with leptin and recording of the impact the treatment had on brain structure and function. Not only did they record a behavioral change and improvement, but also an increase in gray matter concentration and a phenomenon that was reversible upon discontinuation and re-initiation of treatment. Finally, there was a case of a 5-year-old who had congenital leptin deficiency and was mentally retarded. After 2 years of treatment with leptin, not only was he able to improve, but he caught up with the normal development. And also another supporting piece of evidence to suggest that there is leptin role in regulating brain structure and function. So the company overall ascribes to the theme that Alzheimer's disease is a diabetes of the brain. It's type 3 diabetes. And it is a category of compounds that has been pursued by a number of companies, including GSK and Takeda, that explored insulin sensitizers. Insulin itself has also been explored as a potential therapeutic. We believe out of the category, we hold a most promising out of all those compounds because of its safety and tolerability compared to the previous tested, in addition to the fact that there are leptin receptors abundantly expressed in the hippocampus, in addition to a natural saturable transporter that allows the transportation of leptin from the periphery into the brain. This will be a peripherally administered drug for this disease. So this is a novel and differentiated approach. Type 3 diabetes, or diabetes of the brain, is what our category of compounds is, or belongs to. We know that it ameliorates A beta and phospho-tau pathology, and therefore have identified mechanistically a target that is upstream of both A beta and phospho-tau, and that's why we think we get amelioration of those pathologies. because it's a natural protein with pro-cognitive properties and a known safety profile, it is a relatively de-risked and phase 2 ready asset. Of course, previous failures, a number of our speakers today refer to them. They're disheartening. However, we anticipate that there's going to be a lot of lessons we're going to learn from them. I personally, and this is my personal opinion, think that antibodies is a bad, and I agree with Martin 100%, approach in identifying any target in the brain and address its elimination, even if it is the culprit of the disease. Heterogeneity is a major theme that hasn't been addressed enough. We intend to target a very specific subgroup of Alzheimer's disease patients that involves the screening for low leptin individuals and genetically predisposed to convert from MCI to Alzheimer's disease. ApoE4 is one possibility. We're also exploring a partnership with a genetics company or a personal medicine information technology company that uses SNPs to and an algorithm to identify genetically risk individuals. And it is something that we are considering bringing into the mix for our clinical trials. The possibility of the development of this asset as a surrogate endpoint of biomarker is substantially going to be supported by our clinical trials, meaning that we're going to need at least a proof of concept phase 2 linking leptin's pro-cognitive properties in order for us to go to the FDA and have a discussion about an accelerated approval path on a phase 3 that involves leptin as a surrogate endpoint. The phase 1b will involve these enriched patients characterized by low leptin and genetically predisposed to convert to Alzheimer's disease. We intend to get a signal on a number of biomarkers with safety being the primary endpoint, and a phase 2 trial perhaps addressing later stage Alzheimer's disease patients that will allow shorter periods of treatment in order to see a significant change in cognitive outcomes. One note of caution here about our strategy to enrich EE4s that are usually more likely to develop Alzheimer's disease and usually express a disease at an earlier age are not a huge number. In the US, it is estimated that E4 homozygous MCIs are not more than about 400,000. And if we were to address the first quartile, we're going to deal with less than 1,000 patients. Immediately converting our opportunity into our orphan medication, which is not what we want to do. We had a tremendously experienced management team. We have the honour and the delight to have 2 of the people that aren't involved in this room. Thank you for all your efforts and help. And I will not have the time to go into details with more of what the different people in the company have achieved and why we think we're competent and ready in executing as soon as we get the government funding. But here's a summary that highlights essentially what the company is all about and what we're planning to do. MILESTONES is the current name of the asset we are repurposing as Memtin. It's an endogenous protein, a naturally occurring, de-risk asset, repurposing, and replacement therapy. These are major themes of this effort. Just 15 seconds. We have ample, compelling preclinical data, and we are
perfectly positioned to address early intervention and potential prevention therapy for those that are at risk as opposed to early. Most importantly, accelerated approval using the protein and developing it as a surrogate biomarker could be a substantial saver both in time and costs. Thank you very much.